on graphs of functions. Right now, pause the video and find your notebook for note-taking. A spiral-bound notebook is perfect for what you'll need for the course. Note-taking is important so that you have access to what you're learning without having to rewatch all the videos. Plus, you can use your notes on the quizzes. Today, in Module 5, we're going to learn about domain and range. We're going to talk about how to find intercepts of a graph. We're going to find where the function is increasing, decreasing, or constant given the graph, and you're going to choose a graph to fit a narrative or a story. So first, we're going to talk about domain and range. The domain just includes the input or the x values. So you should start a new topic, domain and range from a graph, and you should write down these vocab words. The domain includes the inputs or the x values. The range includes the y values or the outputs there. Don't forget that you have an x-axis and you have a y-axis. So if I'm looking for the domain of this relation, I'm looking for everything that has been used as an x value. So I go to my x-axis and I see that these 2 points have an x value of -4. I see that this point does not have an x value of 4. That's the x value of 0 if I follow it up from the origin. And this one has an x value of 4. When it says use set notation, it's talking about using these squiggly brackets, which you'll be able to click on in ALEKS when you do the practice or when you do your quiz. For the range, again, we're using set notation. Now we're going to be looking at our y values. I like to start from the bottom. So we're looking on the y-axis and we follow this over. That dot has a y value of -4. That dot has a y value of -3. And these 2 dots at the top have a y value of 4. If you need to, you could have also written these points out and then gotten the domain and range from there. For example, this point has a point value of -4, 4. This point has a point value of 0, 4. This point has a point value of -4, -4. And this point has a point value of 4, -3. And so then you can see that your x values are -4, 0, and 4. And your y values are -4, -3, and 4. You pause the video and try this one on your own. Don't forget your domain or your x values, your range or your y values. Welcome back. For the domain, you should have looked at this point and saw that it had an x value of -3. This value has an x value of 2. This point has an x value of 3. And this point has an x value of 4. The range comes from the y value, so I like to start from the bottom. This point has a y value of -2. This point has a y value not of 4, that's the x value, but of 0. This point has a y value of 3, and this point has a y value of 4. When we look at domain and range in the context of a real-life situation, we want to think about what domain and range are realistically possible. So we're on the same topic, domain and range from a graph. You don't need to write down a new topic. You might want to write down this example. If we're thinking about hours in a day, the domain would be 0 to 24. 36 would not be a realistic number, so that would not be included in our domain. And we don't want to forget that we can use compound inequalities to indicate in between. So for example, we've got a machine at a bakery pouring out flour for 4 minutes. At the end of that time, the machine was empty. So these numbers can't go on to infinity. They can't be negative because when our flour runs out, we can't go into negative flour. We can't go backwards in time. The graph shows the amount of flour in grams remaining in the machine in minutes. Find the domain and range of the function shown. So we want to look at our domain, and that's our x value, which is time. For example, here, we've got our x value can be in between 0 and 4 because the time is 4 minutes. So remember, when we show in between, we put our x in the middle. We put the lowest number on the left, the largest number on the right, and we use less thans in between. Could there be exactly 0 minutes when we start? Yes. Could we end at exactly 4 minutes? Yes. So we use equal signs there. For the range, we're talking about the flour. That's what's on the y-axis. And again, that goes in between 0 and up to 400. So we have these in between 0 and 400 with an x in the middle. We use less than and less than. There could be exactly 0 grams of flour, so we use an equal sign. There could be exactly 400 grams of flour, so we use an equal sign. You pause the video and try this one on your own now about the aquarium. Welcome back. For your domain, you should have used your x values. Your x values in this example are time. The time starts at 0 and goes to 20 with an x in the middle. We always use less thans, and exactly 0 and exactly 20 minutes are possible, so we use equal signs for that. For your range, you should have used the amount of water. This again starts at 0 and goes up to 200, so it's in between 0 and 200. Y is in the middle, less than and less than. All right, new topic. I want you to write down that we are finding intercepts from a graph. You've done this before, but we wanted to give you a quick review. So you're going to want to write this down in your notebook. To find the intercepts, we look for the points where the line or curve intersects the x and y axis. There might be more than one intercept. There might be no intercepts. So notice on this one it says click none if applicable. It might be that there are no x or y intercepts. For this one it says give all the x-intercepts and y-intercepts shown. So for the x-intercept, we are looking for where the blue curve crosses the x-axis. Well, that's our x-axis. It crosses here and here. It says if there is more than one answer, separate them in columns, or excuse me, with commas. So there's an x value of -2 and an x value of 0. We don't put parentheses around this because we're not talking about the point -2, 0. We're talking about two different x-intercepts, -2 and 0. The y-intercept, it only crosses the y-axis one time where y is equal to 0, so we just use 0. You pause the video and find your x and y-intercept on your own now. Welcome back. You should have identified your x-intercept as -2 and your y-intercept as -4. Each one just has 1 when you have a straight line. All right, new topic, features of a function. Please write down your topic heading, excuse me. We can use what we know about slope to help us identify where a function is increasing, decreasing, or constant. So when slope is positive, that means the line is going up from left to right. When the slope is negative, that means the line is going down from left to right. When the slope is 0, that means we've got a horizontal line. Well, in the language of functions, this would be increasing, this would be decreasing, and this would be constant. We don't have to worry about vertical lines, which have an undefined slope, because that would not be considered a function because it fails the vertical line test. So we're only talking about features of a function. So it says, use the graph to determine the behavior of the function between the indicated points. So if I want to go in between point A and B, I usually connect those with a line so that I can see in between. And from left to right, that goes up. So that is an increasing part of the function. From B to C, that's horizontal, so that's constant. From C to D, that's going down, so that's decreasing. And from D to E is constant. I would make sure that you have written down at least this stuff in your notes before we move on. You pause the video and try this one on your own. You should have said that between A and B is increasing, between B and C is constant, between C and D is decreasing, and between D and E is increasing. Again, if you think about what you already know about slope, that will make this much easier. All right, new topic, choosing a graph to fit a scenario. So you might want to write this down, a note to yourself. To fit a scenario to a graph, I want you to look at the labels on the axes and then think about whether those should be increasing, decreasing, or remaining constant. So we're applying what we just learned to an actual story. So for this example, it says, for each scenario below, choose the best graph. So our scenario is Bob drives from his home to another state. So you can see that we have time on the x-axis. Well, time should always be going from left to right. It's not going to be this one. We're not going to have one time that we stay at and never leave. Time is always moving. On all of these, time is increasing from left to right, or excuse me, yes, time is increasing from left to right on this one. Time is increasing from left to right on this one. And time is increasing from left to right on this one. So we're going to have to look at the distance from home to clarify this. So Bob drives from his home to another state. This is his distance from home. So when he starts, he should be at 0 because he is 0 miles from his home. And as he drives, his distance from home should be increasing. Neither of these fit that scenario, so we would choose this example. You pause the video and try this one on your own about roasting a turkey. All right, Bob is turning off the oven after roasting a turkey. For time, we can't stay in one time forever. The rest of these are fine on time. Time is increasing over time, that's fine. What we really want to look at is the y-axis. He turns off the oven after roasting a turkey. Well, think about what should be happening to the oven after we turn it off. It should be decreasing. The only one of these that's decreasing is this one, so you would choose that one as your scenario. All right, now let's look at some that have more than just one example of increasing and decreasing. The population of a large city grows very quickly for several years. Then the growth begins to slow and the population remains constant for several years. After this, the population grows again, but slower than before. So I see grows, that should be increasing. I see constant, that means it should be flat, and this should also be increasing. So we're looking for something that increases and then is constant and then increases again. Well, this starts out as constant, so that can't be it. This is increasing, this is constant, but then it's decreasing. We don't have an example of the population decreasing, so it can't be that one. This one starts out as constant, so it can't be that one. This is the only example where the population increases, stays constant, and then increases again. So it would be our fourth option there. You pause the video and try this one about Kayla and the pool. All right, Kayla steps out of the pool and climbs the ladder. So that should be increasing. Kayla waits there getting scared, so she's staying there for a while, so that should be constant. She eventually climbs back down, so that should be decreasing, then gets enough nerve and starts climbing the ladder again. So we're looking for something that's increasing, then staying constant, then decreasing, then increasing. This one is increasing, staying constant, then decreasing, then increasing. So far, I think that one looks like the right answer. But let's try this one. Increasing, staying constant. Oh, this one doesn't have enough information. It fits the first two options, but it doesn't continue. This one starts off with decreasing, which is not correct. She does not start at the top of the ladder. And this one starts out with decreasing. Again, that one can't be correct, so you should have chosen that choice. You're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 5 in ALEKS. Don't forget that if you need help in ALEKS, you can click on Explanation to get extra help. And then to take your assessment, you're going to want to log out, go to the circle with the three, not log out, but go back to the home page, go to the circle with the 3 lines and click on Assignments, where you'll need to do Quiz 5. Have a great day.